Welcome to an introduction to procedural abstraction and Java methods. This week's focus turns to program design strategies, how we can manage writing software solutions as they become larger and more complex. We have actually studied the minimum set of structures that are needed to solve any programming problem. Really, instructions that allow us to put statements in order, make decisions, and repeat lines of code with the use of variable assignments to store information is all we need. However, without the next two major topics, methods and classes, the size and complexity of the programs we can write are quite limited. Without these tools, larger programs are just too hard to write and read and understand and fix when there are bugs. Let's talk about abstraction and programming. First, have you ever had to write a term paper that was more than 12 pages? If you have, you likely remember that you could not just sit down and start writing, even if you had completed a lot of research. When we are tasked with larger projects, we need to use tools that help us plan, organize, and revise our approach as well as tackle manageable pieces in order to complete the entire project. If we want to learn how to build a house, we very well may start with learning how to hammer nails, use a level, paint, and use a screwdriver. Once we are comfortable performing these fundamental tasks, we can start thinking about designing and building larger projects. This has been our approach to learning to code using Java. We have built our fundamental toolkit, but now we need tools that help us plan, organize, and refine our solution strategy. For software development, the complexity and size are managed through abstraction. This is looking more at the larger picture and ignoring the details that can be worked out later. Abstraction and programming, as the programs become large and more complex, we need strategies to organize the solution into manageable units of code. One extremely useful tool is to design a program as a set of cooperating objects that complete the tasks we need done. This is called object-oriented design and programming. We will be considering this more in a week or two. Third, these objects will consist of variable members and actions that act on those variables, called method members. We have studied and practiced with variables. Now we need to get comfortable with methods. Remember, all action takes place inside methods. So far, we have been working inside a method called main. Once we start writing longer, more interesting programs, one method is just not enough. Our goal is to write object-oriented programming solutions. Java classes support object-oriented design and programming. Classes are independent units of code. Here is an example class. Public class example consists of variable members and method members. We distinguish between the variable members and method members because all of the methods will have a set of parentheses after their name. Classes can serve as blueprints for objects. This is a fundamental object-oriented programming concept that allows us to write one abstract unit of code that can be used many times without having to rewrite or copy and paste code. A class, once written, can be used as a blueprint to create many objects. Consider a favorite cake recipe you might have. This is similar to the class blueprint idea, that one favorite cake recipe can be used over and over again to create many actual cakes, just as a blueprint class can be used by Java to create many objects. However, before diving into writing classes, we need to get comfortable with methods. This is a prerequisite for writing Java classes for object-oriented programming solutions. To summarize the power of methods, we're going to consider the method magic. Why we need them? This is the way Java works. We cannot write any code instructions outside of a method. All the actions in a program take place in the context of a method. Organization. This is important because it helps make programs easier to manage. It is always better when writing programs to build small, reusable units of code. Methods help us do just that. Think of a book that is organized into chapters, and the chapters are organized in paragraphs. Now think of a book without any chapters or paragraphs. Yikes! It would be so hard to read, follow, and understand. Java programs are manageable when we use classes and methods as independent, cohesive units of code. This promotes reuse of code and avoids duplicating copies of the same lines of code over and over again. Methods are like subprograms or mini-programs. When we organize our solution into manageable action units, we formulate a big picture of the methods that need to be done. This is like a table of contents in a book. Although Java calls these units of code methods, a more generic term is a subprogram. Other naming conventions include procedures and functions. If you have ever programmed in any other language, you may have used functions, or procedures, or subroutines, or subprograms. These are all different names for the same concept, a reusable unit of code. We have used a program design strategy called input, process, and output. This design tool works very well for methods. We consider the method to be a mini-program in the context of our overall program. Methods are all about performing actions, which corresponds to the process part. Sometimes our methods will meet inputs before they can do their job, and often they will provide outputs to the rest of the program. Here are the 4 variations of methods in terms of inputs and outputs. Number 1, a method with no inputs and no outputs. Number 2, a method with inputs but no outputs. These are often referred to as procedural methods. They are designed to do some process without providing any output to the rest of the program. You can easily identify these in Java programs because they are tagged with the keyword void. Method variation 3 has no inputs but produces output. Method variation 4 takes inputs and produces outputs. These are often called functional methods. Some other languages actually call them functions. Notice that these methods always produce some output. Therefore, they are never tagged with the keyword void. When we deliberate about these, we need to think through the mini-program from the perspective that we are inside the box, so to speak. Think about what the specific individual task is for this part of the program. It's best to keep methods as small and single-purposed as possible. Do one thing and do it perfectly. Keep the focus narrow for each method. So how do we decide which variation we will need? It comes with practice and looking at good code to get ideas for structuring your solutions. We will look at a revised solution to the Putting Together the Pieces Program 1 on calculating the advised aerobic training heart rate. It has been organized into 4 parts, and each one of these sections will demonstrate one of the method variations we see here. Method 1, no inputs and no outputs. Method 2, inputs but no outputs. Method style 3, no inputs that produces outputs. And method style 4, that takes inputs and produces outputs. Here is our no input, no output procedural method for providing instructions to the user. Sitting inside the instructions box, we see that we don't need any information from another part of the program to print to the screen the instructions for the user. Although we print to the screen, we are not producing output to be used by any other part of the program. Notice the use of the void tag in front of the name of the method instructions. This is a signal that there will not be any output from this program code. Also notice the empty set of parentheses after the method name instructions. This implies there will be no inputs to this method. This method simply will print out, "This program calculates your training heart rate." The second variation on a method has inputs but no outputs. This is a second type of procedural method. Again, we climb into the Report Training Heart Rate method box and look at the rest of the program. That is the perspective needed when we formulate the design of the method to report the training heart rate. This method's purpose is to provide the user with the output information after the calculations are completed. It needs input information from another part of the program. Hence, we have two formal input parameters, name and heart rate. We see them passed in inside the parentheses after the method name report training heart rate. Although it will write to the screen as output, it does not need to send any information back to the rest of the program. And we notice that it too has the void tag in front of its name. This sends the signal that there will be no outputs. The third type of method has no inputs but produces an output to be used by the rest of the program. This is often referred to as a function style method because it produces a result that our program will use. These are function style methods that some other programmer wrote, and when we use the nextInt method, it returns a value of type int. We use that returned output to assign to the age variable. The nextLine method returns a string value, which our program uses to assign to the name. Remember, our point of reference is inside the process box, looking at the rest of the program code. Since these methods get input from the keyboard that was typed by a person who is outside the program, there are no inputs from another part of the program. Notice the parentheses are empty. That would be where we would put the inputs. There are no input parameters inside the parentheses for nextInt or for nextLine. However, the job of this part of the program is to provide the rest of the program with information that we solicited from the user. Therefore, we must provide three pieces of information to the rest of the program. We need the age that we retrieve from the nextInt method. We need the name that we retrieve from the nextLine method. And we need the resting pulse that we retrieve using the nextInt method. Frequently, the processing part of the code will require inputs to perform its task and also produce outputs for the rest of the program to use. This is our fourth style of method. This function method has two inputs, the age and the resting pulse. They will be passed in inside the parentheses in the code of calculate training heart rate. They are used to do the calculation for the training heart rate. The calculated result will be output from the method. That is why we see the word double in front of the method name. This indicates the method will return a double type value to the program, and that is done using the return statement. Here is the main method. We will always use the main method to be the starting point of our programs. This is a small program that ordinarily would not need to be organized into separate methods, but it does provide us with a simple example of organizing a solution into subprogram units, and it allowed us to examine the four varieties of methods in terms of inputs and outputs. In order to execute the methods, other than main, which Java knows to start execution at, we need to call them by name. Let's look at them being called to execute by main. After the list of variables, we see the call to the instructions method. Notice there are no inputs provided to the instructions method, and there are no outputs from this method either. Its job is just to provide instructions to the user. The next method call we have highlighted is the getInput.nextLine method. This is a function style method that returns a string value that we assign to the name. Then we nextInt the age of the user. Again, getInput.nextInt is on the right-hand side of assignment. This tells us clearly that it's going to supply us with a result that we will store in variable age. We repeat this process again to get the resting pulse using function style method nextInt. After we have those inputs, we pass two inputs to the calculate training heart rate, the age and the resting pulse. After that is done doing its process, it returns an output of the training heart rate that we assign to variable training heart rate. Our last call to a method is the report training heart rate, takes two inputs, the name and the training heart rate, and does not produce any outputs for the rest of the program. It just prints to the screen the name of the user and their recommended training heart rate. Notice both instructions and report training heart rate, the procedural style of methods that are void methods without any output, are on lines by themselves, where the functional style methods, next line and next int and calculate training heart rate, appear on the right side of assignment statements, meaning they return a value that gets used by the program. Let's recap our first overview of methods. Methods can be thought of as subprograms or mini-programs. They always perform some type of actions. They can have inputs, but they don't have to. They can produce output results, and when they do, we refer to these as function methods, and they must have a type. Or maybe they are void methods. This is the procedural method that doesn't supply any outputs. Methods need to be called in order to be executed, except for main, which is automatically called by Java. You can find the sample code in this week's timeline materials. Please download this revised training heart rate code and try it out. Although it is packaged differently, it will still run the same. Happy Java coding!